Hello everyone, in this video we are going to see about the representation of linked list. So linked list is one of the linear data structure. Let us see in this video how the linked list is represented in the memory and also how the traversal of linked list takes place. Let us see the block diagram of this linked list. This is the way the linked list is represented in memory. So here the list always starts with the head and it ends with the null pointer. And here every node, this block is called a node, and this is another node, and this is another node. So it is a collection of nodes. It's a chain of node. So each node consists of two portions or two components, the data and the next. Actually, what does the data represent is the content of the memory location, and next is the pointer that points to the next location where the data is stored. The next data to the previous data is stored, that is pointed by the next pointer. So this is the way the pointer helps to go through the list till the end of the list null is reached. A definition: a linked list is a linear data structure in which the elements are not stored at contiguous memory locations. That means the elements are not in the continuous positions. Wherever memory space is available, the data will be scattered in the memory, and how they are followed using the pointers. A linked list consists of nodes where each node contains a data field and a reference link to the next node in the list. So this is the node, contains a data field and the reference field. The elements in a linked list are linked using the pointers as shown in the below image. So now here we can follow the linked list by the pointers. So these are all the pointers that address to the next consecutive element. Even though the elements are not stored in the consecutive contiguous memory locations, this pointer helps to locate the successive elements using the pointers. Let us see with an example how this data is represented in the memory. For example, you are storing the word called name hello. Here we can see HELLO. So these elements are not stored in the continuous locations. They are scattered somewhere in the memory wherever the spaces are available. Now this is you have to start the representation. So this is the starting node called as the header. So from the header, this will points to the first element. So here the first element is H. So this pointer points to the address of the element H. This is called as an information field. And next, this block is the link or the next field. This will link to the next address where the next letter is stored. And then likewise, by following the is pointer, you can go to the else pointer and so on. Finally, we reach the end of the list, which is the null value. Let us see how it is stored in the memory. So now for example, the starting location is 9 to store this word hello. So now this is the contiguous memory locations, but we can see that the elements are not stored in contiguous memory location. So here the starting position is 9. So we have to go to the 9th position. In 9th position, the letter H is stored, and then H contains an equivalent pointer 4. That means the next data of H is stored in the 4th location. So go to 4. 4 contains E, and then E's pointer contains 6. That means next to H is E, and next to the word and letter E is stored in location 6. This 6 shows the address of the next letter. So now I have to go to the 6th position. There L is stored, that means the next letter is L, and then for that pointer is 2. So we have to go to the 2nd position. Again letter L is there. So we have to coin this way. The first word is H followed by E, followed by this L, and followed by this L, and finally this L has the pointer as 8. That means 8 contains the next letter. So come to 8. So 8 contains the letter O, and now we can see that the pointer of this letter O, which is 0, that means the list is over. We can come to the end of the list. So this is how the elements of this linked list is traversed, or they are find out. Now the same is explained in this given here over here. So you start with the 9 and then information of 9 is the first character and the link of 9 is 4. Then we have to go information of 4, E is the second letter and then link of 4 is 6. Then go to the 6th position, L is the third character, and likewise you have to follow the pointers so that to get the continuous location of the letters, and finally the null value list ends the list over here. So this is how the linked list is represented in the memory. Now here is an example having the there is a pair of values. So this contains the two pair of values and the values are given as 88, 77, 93 and 82 for one list, and then this 84, 62, 74, 100, 74, 78 are the score of the next list GEOM. So this is the value of the list ALG. So now you can see that this ALG starts from 11. So what is the 11th position? Go to 88, that is the first letter. Then how to follow the next one? The pointer of this letter, the test X 88 is 2. So go to the 2, which is 74. From 74 go to 14. What is 14? Come back to 14. Then 93 is the next one. So 93 points to 4. So 4 is 82. And then 82 has 0. That means the node 4 of ALG is over. That means we have followed all the 4 values 88, 74, 93 and 82 by the list value. Now we have to go to the next one, which is GEOM, that is the test score. This geometric test score contains 88. So 1, 2, 3, 4, 5, 6. So how to follow the pointers? So the first location starts from 5, then go to 5. First is 84, then this shows the address 12. So come to 12, 62, that is the next value. Then the address is 7, go to 7th position, next value is 74. You can see the list over here. This is how the list is generated, and from 74, 8 is the location, go to 8, which is 100, then 100, the location is 13, go to 13 location, the value is 74. So you can see after 100, 74 we got, and then finally 6. So 6 is the position containing the value 78 and then 0. So with this the list GOM also over. So this is the way how to follow the list with the double values. So this is the two list representation. And now let us see the traversal algorithm. What is traversal is starting from the head and going to the till the end of the pointer to reach the null pointer and visit all the values. That is called as a traversal. So any algorithm that visits all the node is the traversal algorithm. So how the algorithm steps goes? The first step is begin from the head, because you have to start from the header and then check if the end of the list has not been reached yet. That means we have to traverse the whole list as long as the end of the list is not reached. So what you have to do some actions with the current node which is specific for the particular algorithm. That means some algorithm traversal means visiting, summing up the values means sum the values node by one, printing means print the values node by node. So whatever the actions you have to do, that has to be performed on every specific value in the particular node. And then current node becomes the previous node and next node becomes the current node. So now the pointer moves, and the pointer keeps on moving, the next node becomes the previous node, and then the next node becomes the current node. Okay, so how this is the way we can successively go through the continuous nodes. Then one work is done, go to step 1 beginning from the head. Okay, so this is the way this routine continues to traverse the whole set of elements in the linked list till the end of the list is reached. Now let us see the algorithm in the specific format. So now set PTR is equal to head. We are starting from the head position. So step 1 is set the pointer to head. Next, step 2 is if PTR is equal to null, means if you have reached the pointer, then write empty list. Immediately if you reach the null after the head, that means the empty list is empty, nothing is there in the list. Otherwise else go to step 6, end of if. So if is over. Okay, and then Step 3 is repeat step 5 and 6 until PTR not equal to null. What does it mean is go through all the steps 5 and 6 as long as the end of the list is reached. End of the list is denoted by the null operator, null point value, null data. So next step 4 is print PTR of data. So this will print the data which is pointed by the PTR pointer. Step 5 is PTR is equal to PTR arrow next. That means this will traverse successively. So this will point to the consecutive node by using the PTR is equal to next. And then end of the loop. So what is the loop here? This is the repeat step is the loop. So repeat these steps. That means do some work on the data and then move to the next data till the end of the data list is reached. So now here end of the loop, that means the steps 5 and 6 are repeated, and then once the end is reached we have to exit the loop. Okay, so totally here if the pointer is null means it's an empty list, directly go to step 6. Otherwise repeat these steps and then you have to do the operation, then go to the next step which is the exit one. So this is the one traversal algorithm that helps to traverse the linked list. Here the work done is only printing of the data and pointing to the next data. So example is given over here. Now an example shows how to sum the elements of the linked list. So we can see from the example here. So 5, -1, 16, 2. These are all the values of the nodes. Now we are in this is the previous node. We are going to start from the previous one. That means we are going to start from the first location using the pointer, consecutive moving of the pointer. So initially sum is 0 because nothing is added. Okay, initially nothing is added, sum is 0. Then now the pointer, this previous becomes the, now here this current is given by -1 and this previous is the 5. So in the previous step 5 is the current position and previous is null. Once you move the step, this current will become the previous one and the next will become the current one. Likewise, this current become the previous, next become current. Current become the previous, next become the current, and here finally current become the previous, and since there is no consecutive elements it will become the current, but which is the end of the list. Okay, so now let us see how the sum is done. Initially sum is 0, nothing is added. Now step 1 sum is equal to 5. Why? Because sum is equal to 0 and then this 0 is added with the first element 5. So 0 plus 5 is 5. So in step 1 sum becomes 5. Now the pointer moves to the current location. Oh, then what is step 2? Sum is equal to sum plus the current one. So what is sum plus current? 5 plus -1, which is 4. Sum is equal to 4. Again move to the pointer is moved to PTR is equal to PTR arrow next. Now the pointer points to the element 16. Now the sum is 4 and the current element is 16. So -4 plus 16 is 20. So after this step the sum becomes 20, and then here the pointer moves to the next element. So the sum is 20, then you have to sum the value 22. Now the answer is sum is equal to 22. Finally there is nothing to move, and we have reached the end of the pointer, end of the list. That's all, the process is over. So thus by following the previous and the current pointer, successive elements are reached by the pointer reference and the sum is calculated step by step for all the elements of the linked list. So this is one example of how to traverse through the linked list and find the sum of the elements. So this is one example for traversal, and here the process done is summing of the individual elements of the list. So that's all the concept of linked list travel. Hope it is easy to follow, and thanks for watching.